Okay, this is the worksheet dressing up y equals x squared. I'm going to go through from the beginning. I'll leave you to read the basic part at the top as to what we're going to be looking at in this section, and come down here to start with the basic function y equals x squared. So to do this, we're going to fill in the table here. So when, just let me get my pen in position here. When x is -3, -3 squared is 9, -2 squared is 4, 1, 0, 1, 4, 9. And we're going to go over here and graph these points. So let's start with 0, 0, 1, 1, 2, 4, and 3, 9. And then symmetrically on the other side, -1, 1, -2, 4, and -3, 9. We have the parabola. We'll now join that with a smooth curve, which on here might not be that smooth. And arrows to show that it goes on forever. This is, of course, a little bit shaky looking. And another set of arrows. So that's our basic graph of y equals x squared, and we need to be familiar with the characteristics of it. I'm going to show it to you in another way. There's a program called Desmos, DESMOS.com. And I'm going to go up here and type in y equals x squared. And here's our parabola again. I'm just going to drag this down so we can see a little bit more of it. And you'll notice if we move over 1 unit on the x-axis, we go up 1 unit. 2 units on the x-axis gives us 4. 3 units, which will be here, gives us 9, which is up here. And this is, of course, a much smoother curve. Okay, back to the worksheet now. And let's just move down a little bit. So the shape of the graph is lost my cursor, here we go, is a parabola. Coordinates of the vertex are 0, 0, and the equation of the axis of symmetry is x equals 0. Moving on to part B, we're going to look at the effects of a on y equals ax squared. And instead of this website here with the Ron Blonde, you can look at that website, but we're going to go to Desmos.com. And what we'll do is go back to that, create a slider, and take a look at what happens when we change the value of a and answer these questions. Okay, we're back. I'm going to go into here, edit this, put in an a, and add a slider. And I want you to watch what happens as I slide this, increasing the value of a. We can see the parabola is changing shape, decreasing the value of a, notice what's happening, and as it becomes negative, notice what happened. Okay, so let's answer the questions. Does changing the value of a change the position of the vertex? No. In general, what effect does a have on the graph? It changes the width of the parabola. And remember, you can find all of these answers on the Schoology site. As the absolute value of a, so this symbol here, I try and get over there, this symbol here means absolute value, which is just the magnitude. If a is negative, you make it positive. If it's positive, you leave it as positive. As the absolute value of a increases, what happens to the graph? Okay, we're back in Desmos. I'm going to make a larger and larger, and we can see that the graph gets narrower. Okay, so the graph gets narrower. if the absolute value of a is greater than 1, so as we go 1, 2, 3, 4, 5, 6, we know that this graph is narrower than y equals x squared, and we say we have a vertical stretch by a factor of the absolute value of a, whatever that expression is, resulting in a vertical expansion. If the absolute value of a is less than 1, so between 0 and 1, let's pause for a second, we'll go back to Desmos. So I've taken the value of a back to 1, we're back with our regular y equals x squared, the starting position. As I lower the value of a, you notice that the graph gets wider. And if a goes to negative, then the graph reflects over the x-axis. So here we are, if the graph, if the absolute value of a is less than 1, then the graph of y equals ax squared is, and I have lost my pen. Give me a okay, back. If the absolute value of a, then the the absolute value of a is less than 1, then the graph of y equals ax squared is the graph of y equals x squared, and we say we have a vertical stretch by a factor of, this will be the absolute value of a, resulting in a vertical compression. That's as if we're squashing the graph down. When a is positive, the parabola opens up, and when a is negative, the parabola opens. And I'm running down. On your graphing calculator, graph y equals x squared. Okay, so you read number 6, and we will do that in depth. Okay, we have y equals x squared and y equals negative x squared. We're going to graph y equals 3x squared and y equals negative 3x squared. And as you can see, we have congruent parabolas, the narrower ones being the 3x squared and the negative 3x squared, and the result was that we have reflections of each other with respect to the x-axis. So these are reflections, reflections with respect to the x-axis. I'm not too good at writing on tablets yet. Let's take a look at number 7. Whoops, I'll scroll down. We have some graphs, y equals x squared, 3x squared, 0.4x squared, and 5x squared. We need to determine which is which. So we know y equals x squared. If you're over 1 unit, you should be up 1 unit. Over 2 is 4, and 3 is 9. So this curve here is y equals x squared. And again, I've lost my pen. Okay, so where are we? This is y equals x squared. The narrower we get, the larger the number. So this will be 3x squared here, and this one is 5x squared, and this one is 0.4x squared. 0.4x squared, 3x squared, and this one here is y equals 5x squared. These two other parabolas are reflections of the parabolas we have above, this one being a reflection of 3x squared. So its equation is negative 3x squared, and we have y equals negative 0.4x squared, the leading negative giving us a reflection in the x-axis. Number 8, compare the points on the graphs of y equals x squared, y equals 1/2 x squared, and y equals 3x squared with an x coordinate of 1. What do you notice about the y coordinates? Okay, let's pop over to Desmos here. We have y equals x squared, has the coordinate 1, 1. Y equals 3x squared has the coordinate 1, 3. Okay, I can click there, and 1, 3, 1, 1, and 0.5 gives us 1 and 0.5. So what do we notice? We notice that the y-coordinate is equal to a. So on these, the y-coordinate is equal to a. Coordinate is equal to a. Okay, now graphs are provided for us, so we're looking at part C, the effect of p on y equals x minus p quantity squared. We have y equals x squared, y equals x minus 4 squared, and y equals x plus 2 squared. Are the graphs the same shape? That is, are they congruent to each other? And the answer to that is yes, they are. So p does not affect the shape. Then what effect does p have on the graph? Well, we can see that these graphs have been moved left and right. We call that a horizontal translation. Horizontal translation. And in part C, we're asked to state the vertex of each of the functions. Let's just drag down there. We see the vertex of y equals x squared is 0, 0. This vertex is 0, 4, or sorry, 4, 0. 4, 0. And the vertex for this is negative 2, 0. So you'll notice that the vertex has the opposite sign of the number. X minus 4 moved 4 units to the right, giving us a vertex of 4, 0. So using that information, the graph of y equals x minus 7 squared is the graph of y equals x squared translated horizontally 7 units to the right. And the coordinates of the vertex are 7, 0. The graph of y equals x plus 5 squared is the graph translated 5 units. So we also have to say how many units and which way. To the left. The coordinates of the vertex are negative 5, 0. Parameter p translates the parabola horizontally p units relative to the graph of y equals x squared. If p is a positive value, the equation will look like y equals x minus p quantity squared, and the graph is translated to the right. And if p is a negative value, the graph is translated to the left. And the coordinates of this will be p, 0. Number 3 is state the equation of each of the parabolas shown. So part A, we can see that this parabola has moved 4 units to the left. So it'll be x plus 4 squared. For B, we can see it's 1 unit to the right, y equals x minus 1 squared. And for C, it's moved 3 units to the right, x minus 3 squared, but it also opens down, so it's negative x minus 3 quantity squared. Now, part D, the effect of q on y equals x squared plus q. We have 3 graphs shown, x squared plus 3, and x squared minus 5. They may not look congruent, but they are, and you can prove this for yourself by going into Desmos or graphing these on your graphing calculator and looking at them, and you'll see that these graphs really are congruent. So q does not affect the shape and size of the graph. That's A as a matter of fact. Then what effect does q have on the graph? Well, it looks like it moves it up or down, and we call that a vertical translation. Okay, let's state the vertex of each of these shown. Vertex of x squared is still 0, 0. This moved up 3 units, so it'll be at 0, 3. And this moved down 5 units, will be at 0, negative 5. Okay, part D, complete the following statements. The graph of y equals x squared plus 8 is the graph of y equals x squared, translated vertically. I lost my pen again. Vertically, 8 units, and when we do a translation we have to say which way, so this is 8 units up. The coordinates will be 0, 8. The graph of y equals x squared minus 10 is translated vertically 10 units. So how much and which way down? The coordinates of this will be 0, -10. Parameter q translates the parabola vertically q units relative to the graph of y equals x squared. If q is a positive, then in this case it really does what you think a positive will do. It will translate up, and if q is negative, it will translate down, and the coordinates of the vertex will be 0, q. Now let's state the equation of each parabola shown. So looking at A, we can see that we have the graph y equals x squared translated 5 units up, be x squared plus 5. B, we have the graph of y equals x squared translated 2 units down, so -2. And C, y equals, well, it's negative x squared because it opens down, and it's translated 1 unit up, so negative x squared plus 1. Okay, part E, putting it all together. Suppose you want to sketch the graph of y equals -2 x plus 3 quantity squared plus 4. How do you handle all three, actually 4 transformations? First, you have to determine the effect of each of the numbers. So the transformation the 2 makes is a vertical stretch. And a very important skill you'll need to develop is to be able to go from the equation to a description in words. Vertical stretch by a factor of 2. The negative sign causes a reflection in the x-axis. The positive 3x plus 3 is a horizontal translation. Horizontal translation. And that goes left 3 units. And plus 4 is a vertical translation. For units. Up. When we talk translations, you have to go which way and how much. So left 3 units, or 3 units left, and 4 units up, or up 4 units. We're going to graph this. We're going to do it in 4 steps. We're going to start off by just graphing the general graph y equals x squared. Okay, let's start with our vertex at 0, 0. We have 1, 1, 2, 4, 3, 9. And again, this is symmetrical about the axis of symmetry. So there's our basic y equals x squared parabola. I'm going to try and sketch, putting arrows on both ends. That's our starting y equals x squared. Next thing we're going to do is we're going to stretch this vertically by a factor of 2. So everything is going to be twice as high as it was. The vertex will stay at 0, 0. The point which is at 1, 1 will now be at 1, 2 because we're multiplying. We square 1. 1 squared is 1, but then the a value is 2. We get 1, 2. 2 squared is 4, but we're multiplying by 2 gives us 2, 8. 3 will be too high for us to look at, so we can't plot that. And we have negative 2, 8. So this is our stretched and somewhat shaky parabola. And again, arrow. So that's stretched by a factor of 2. I would encourage you to graph that on your calculator or graph it on Desmos to get a cleaner look. And we'll scroll down and finish this. Okay, the next step is to reflect in the x-axis. The point 0, 0 will stay where it is. The point that was at 1, 2 will become 1, negative 2. The point that was at 2, 8 becomes 2, negative 8. And the point at negative 1, 2 reflects, becomes negative 1, negative 2. So basically changing the sign of the y value. And negative 2, 8 becomes negative 2, negative 8. This is our reflected parabola. And not so hard at drawing on a tablet. But again, you can graph that. And our last step is to take each of these points and do the final transformation, which is 3 units to the left and 4 up. So let's start with the point that was at 0, 0. We'll now move 3 units left and 4 units up and be at negative 3, 4. The point that was at 1, negative 2 moves 3, 1, 2, 3 left, 1, 2, 3, 4 up. Point that was at negative 1, negative 2 moves 1, 2, 3 left, 1, 2, 3, 4 up. The point that was at 2, negative 8 moves 1, 2, 3 to the left, 1, 2, 3, 4 up. And the point that was at negative 2, negative 8 moves 1, 2, 3 to the left, 1, 2, 3, 4 up. And I should know to leave well enough alone, but I will try and draw this as a parabola and an arrow and coming down. And that is our result. And I'm just going to pop into Desmos and we'll watch that again, only this time I'll do each of the transformations. So we started with y equals x squared. We changed that to y equals 2x squared. You can see we have the narrower. Let's create a new expression. We then reflected. We got y equals negative 2x squared. So there it is opening down. And finally we did the two transformations, giving us y equals negative 2 bracket x plus 3 bracket. You won't see anything happen until we get the squared on. So that's moved the parabola, the reflected parabola, 3 units to the left, and then we're going to add 4 plus 4, and there's our final result, which the points of which should match up with what we have on the page over here, although the line itself is a little bit shaky. Okay, I'm going to pick up with part F in the second part of this video. This first part is for review, or for those who were away when we did this particular thing.